Hey guys, my name is Shreyas and welcome to Simple Chemistry. In this video we're going to be talking about the common exceptions that we see within nomenclature. So the first exception we see are peroxides. So if you look at this compound here, you might notice something a little funny. We know that magnesium always has a +2 charge in ionic compounds because it's in this column of the periodic table. And we know that oxygen always has a -2 charge in ionic compounds because it's in this column of the periodic table. Now, we see that we have one magnesium ion, but we have two oxygen ions, which is a little weird because this magnesium has a +2 charge, and then each oxygen has -2. Multiply that by 2, you have a -4. +2 -4 is giving an overall charge of -2, but this compound is electrically neutral. So what's going on here? So this O2 here is actually a special ion called peroxide, and peroxide is O2, and it has a -2 charge. So here you would not call this magnesium oxide. Magnesium oxide is just this. You would name this as just magnesium peroxide, okay? And that goes with any metal plus peroxide. You would name it exactly the same as how you name any other binary ionic compound, except that instead of saying oxide, you call it peroxide. Now, in the case of when we have hydrogen with peroxide, even though this is actually a binary covalent compound, we're just going to name it hydrogen peroxide. Alright, pretty simple. Now let's go into the common names. So these compounds here are typically not named with the rules that we've learned in this unit. Alright, we don't typically call this dihydrogen monoxide. We just call it water. Here, this is NH3. We don't call this nitrogen trihydride. The common name for this is ammonia. And this here, we don't call this carbon tetrahydride. It's called methane. Okay, so whenever you see this, don't use the common rules. Name it using these. Sorry, don't name these compounds using the nomenclature rules that we've learned in this unit. Actually, use these names instead, because these are the common names for these compounds, which scientists usually use. Okay, and finally, acids. So if an acid is in solution, meaning it's dissolved in water, we use the common rules that we've learned. However, if it's in the gaseous state, meaning that it's not dissolved in water, we name it as hydrogen plus the ion name, or the element with the IDE ending. So for example, let me give you these two examples. Let's say we had HCl, okay, but it's in the gaseous state. Okay, it's not dissolved in water. So we would not name this hydrochloric acid. Instead, we name this hydrogen chloride, like this. Another example of that, let's say we had H2S in the gaseous state. If we wanted to name that compound, okay, again, this is in the gaseous state, meaning that it's not dissolved in water, we would name this as hydrogen sulfide. Okay. Now, let's say we had a ternary acid. This is a little different here. Let's say we had H2SO4, but it's not dissolved in water. We would name it dihydrogen sulfate. Okay, so with the binary binary acids, if they're not within if they're not in solution, we just say hydrogen chloride even if the number of hydrogen atoms is more than one. Okay, but with ternary acids, we have to indicate the number of hydrogens. Okay, so that's all exceptions you need to know. So make sure you account for them whenever you're naming acids, peroxides, and using those common names. All right, but that's it for now. Exceptions in nomenclature are simple as that.